another night, another live session of free math tutoring. I am Mrs. Taylor, and you are in Mrs. Taylor's math class right now. So if you would need some help with some math, you can text me at 407-801-9255, and I will help you out with your math problems. Again, that number is 407-801-9255. Other than that, if no one texts me, I will be doing some 8th grade math tonight. So if you're interested, stay tuned. Alright, so 8th grade math. So for the 8th graders, it says, some of these problems I'm going to do tonight, some of them require calculators, some of them do not. So I'll probably be using a calculator to speed up the process on some of the problems. So it says, what is 0.3600 repeated, written as a fraction? Now, when teaching this lesson here, it is always a little bit complicated for the teachers, I think. But for the most part, it's okay. So what you would want to do, the first thing you do is you start out by having x equal to the repeating decimal, which is 0.36. So I'm going to write it 2 times. And then when I put the 3 dots behind it, that means it still is repeating. Then the first thing you want to do is multiply both sides by 100. Now, the reason why you want to do 100 is because the 6, when you're looking at this decimal here, 0.36, this is in the hundredths place. Okay? So you would need to multiply both sides by 100. So when you do that, you get 100x is equal to 36.3636 repeated. Okay? Now, to figure out how do I get rid of the repeating part, you need to do a subtraction now. So you would need to subtract 100x minus x on the left-hand side. And on the right-hand side, you're going to say the 36 repeating, 36.3636 ... And I'm going to write the subtraction like this so you can see exactly what I'm doing. ... So I want to get rid of the repeating portion of this decimal. So on my left-hand side, I'm left with 100x minus 1, which is going to be 99x. On the right-hand side, I'm just going to subtract everything. All of this behind the decimal is going to be 0, 0, 0, 0, ... Over here before the decimal, you get 36. Okay? So really, you're just left with 99x is equal to 36. And so you would just need to divide both sides by 99. Okay? And so x is equal to 36 over 99. But chances are they're going to want you to give a simplified answer. The answer 36 over 99 is not incorrect. It's just not simplified. So I can divide both my 36 and my 99 by 9. And when I do that, I get 4 11ths. And that is going to be the value of x. Or that's going to be, if I wanted to write it correctly, 0. repeating 36 is going to be 4 11ths as a fraction. So write it as a fraction, and that's what you get. So we'll make that our final answer. Let's go to another problem. Remember, tonight is dedicated to 8th graders taking pre-algebra. Usually that's what it's called. But it's 8th grade math. And of course, I'm using the Florida standards. Let's go to another problem. So this problem here says a number line is shown. Place the following numbers in the proper location on the number line. So before I actually do place them on the number line, I want to show you your perfect squares. So we know that 1 squared is equal to 1. So the square root of 1 is 1. 2 squared is equal to 4. So the square root of 4 is 2. And I'm going to keep going just for just a couple more. 3 squared is going to give me 9. Square root of 9 is 3. 4 squared is 16. The square root of 16 is 4. And 5 squared is equal to 25. And so the square root of 25 is going to give me 5. And I'm going to stop right there because I think this is enough for just this particular problem. So when you're looking at where to place these numbers on a number line, you need to put these radicals in between the two perfect squares that it goes to. So if you look, you have the square root of 3. Well, the square root of 3 is in between the square root of 1 and the square root of 4. But what does the square root of 1 equal? It equals 1. What does the square root of 4 equal? It equals 2. So that means that this irrational number here, the square root of 3, is going to be between 1 and 2 on the number line. So I don't know exactly where it's going to be. I'm just going to put it here. So I'm going to call that the square root of 3. Now let's look at the square root of 8. The square root of 8 is going to be in between the square root of 4 and the square root of 9. The square root of 4 is going to equal 2. The square root of 9 is equal to 3. So that means that the square root of 8 is somewhere in between 2 and 3. So I'm going to put that on the number line. So we'll put the square root of 8. Okay, now the square root of 23. Well, that's in between the square root of 16. Let's use a different color. Hold on. So that's going to be in between the square root of 16 and the square root of 25. So this is going to be 4. The square root of 16 is 4. The square root of 25 is 5. So the square root of 23 is in between 4 and 5. So we'll put the square root, that's the square root of 23. So this is the expectation that 8th grader needs to be able to do a problem like this. This is what the state expects them to know how to do. So this question here, I believe, is a no calculator question. So they would have to know their perfect squares. Let's keep going. Okay, so here it says which expression is equivalent to 1 over 27. Now this problem here, you have to know your, what is it called, the radical rules, the exponent rules, when they have the same base. So the base of all of the problems here is 3. And you want to know which one is going to get you the answer 1 over 27. So of course, in order to do this, you have to analyze each answer choice. So let's start with A. So with A, answer choice A, you have 3 to the first power times 3 to the negative 10. So the rule is if you're multiplying two numbers with the same base, and the base is 3, you need to add their exponent. So I'm going to say 3, and then this will be 1 plus negative 10. So I can just write it like this. And so that's going to get me 3 to the negative 9. Now, anytime you have a negative exponent, you need to actually like do the reciprocal. So right now it looks like this. This is what the problem looks like. But for me to do the reciprocal, it would be 1 over 3, and I'm going to change the negative 9 to a positive 9. Now, 3, let me make sure that looks right, because I need to make sure this is real clear. Let me change the thickness of my pen. So we have 3, and then the exponent is 9, okay? This does not equal 27. This number is going to be big, so, well, at least the denominator portion. What it means is you're going to have 1 over 3 times 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 3. That should be 9 threes. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm not going to calculate that. I know that that does not equal 27. So I know that answer choice A is not my answer. Okay? So let's go to another one. Let's look at answer choice B. So for answer choice B, I have 3 to the negative 1 times 3 to the positive 10. Again, if you have the same base, you need to add the exponent. So this is 3, and this is negative 1 plus 10. This is going to get you 3 to the 9th power. For this one here, again, first off, it's not going to be a fraction because you do not have a negative exponent. But you do have to multiply 3 9 times. So basically, you're doing the same thing you have in the green. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is whatever number it is. I'm not going to calculate it. I know that answer choice B is not my answer. Let's do another one. So for answer choice C, we have 3 to the negative 4 times 3 to the 7th. Again, they have the same base, so you need to add the exponent. So this is going to be 3, and it's going to be negative 4 plus 7. That's going to get me 3 to the 3rd power. Now, 3 to the 3rd power is a lot more friendlier than 3 to the 9th power. So if I say 3 times 3 times 3, that does get me 27. But I want 1 over 27, so answer choice C is not an answer. So now let's go to answer choice D, which has to be my answer. So let's check it out. 3 to the 4th times 3 to the negative 7 is, again, they have the same base. You have to add the exponent because you're multiplying. So this is 3, and this is 4 plus negative 7, or I could just write 4 minus 7. And I'm going to get 3 to the negative 3rd power. Now again, when it's like that, you need to switch it around. So this is going to be 1 over 3 to the positive 3rd power. And I could go ahead and multiply this out. 3 times 3 times 3. And just like in the previous problems, you know that multiplying 3 3's together is going to get you 27. So this is 1 over 27. So my answer is going to be D. This, I'm not sure if you can use a calculator with this type of problem. Let me look, because I did have this. I had it written down, like which one you can use a calculator with. Oh, no, you can't use a calculator with this type of problem. So, 8th grader will have to know how to do this problem without a calculator. And that's just knowing your exponential rules. Your exponent rules. So, let's go to another problem. Here's another one involving exponents. So it says select all the expressions equivalent to 4 to the 3rd power raised to the 2nd power times 4 squared. So no, you are not allowed to use the calculator here. So you would have to actually know your rules for exponents. So this first one is a representation of a power of a power. And so when you have power of a power, you need to multiply those exponents together. So if I have 4 to the 3rd power, and then that's raised to the 2nd power, that's going to get me 4, and I'm just going to multiply these two numbers together. So 3 times 2 is 6. And then over here, I still got the 4 squared. So remember from the previous problem, if they have the same base, you just add the exponents. So this would be 4, 6 plus 2, and you have 4 to the 8th. Okay? So guess what? That's one of my answers, so I'm going to pick this one. I would pick this answer choice, okay? but there are more. So I have to figure out, well, what's going to be my other choices. So if I'm looking at my answer choices, I know I have to have a base of 2. Well, what I know about the 4 is that I can rewrite this with a base of 2. So let me pick this line right here. Let's go to this line here. And I'm going to rewrite that 4 to the 6th power. So 4 to the 6th power, I can rewrite that as 2. Let me start. I don't want to go that route. Hold on. I want to say 4 squared times 4 squared times 4 squared. I could do that. Or what I could do is just say 2 squared. Okay, and then put the 6 out here. So I rewrote the 4 as 2 squared, and then still raise it to the 6th power. Now when I do that, then it is a power of a power, just like this type of situation up here. So I can rewrite this as 2 to the 12th power. And guess what? That's one of my, well, I'm not all the way to the answer choice yet. Hold up. I still have to multiply it times the 4 squared. So I got to take this portion here and multiply it by 4 squared. Well, remember, I can rewrite this one as well. So I got the 2 to the 12th power, and then I can rewrite the 4 as 2 squared. And then put the actual square here. Okay? So now this is going to be 2 to the 12th times 2 to the 4th. And then I can add my exponents together, and I have 2 because I have the same base and I'm multiplying. I can add the exponents, 12 plus 4, and I get 2 to the 16th power. Okay? And that is one of my answer choices. So I would select this one as well. Now for the next one. Let's go back to what I started writing. So if I take this line here, this 4 to the 6, this one right here, let's bring this down. Let's bring that right there. So I have 4 to the 4 squared times 4 squared times 4 squared. Remember that came from 4 to the 6. Then I still have this portion here that I need to add on. So this is going to be times 4 squared as well. Okay? Now what is 4 squared? 4 squared is really 4 times 4. What's 4 times 4? It is 16. So I can rewrite these as 16 times 16 times 16 times 16. Each one of the 16s has an exponent of 1. Okay? So now I can say, well, they have the same base. I can add all the exponents together. So the base is 16, and then I add the exponents. Okay, so now I'm left with 16 to the 4th power. And guess what? That's one of my answer choices. Now, the rest of the answer choices are not it. So I am done with this problem. But here's the thing. These kind of problems here, they are not hard, but they just take time. And man, we got to build our kids' stamina when it comes to having patience and to do these types of problems, because they get frustrated. They don't want to take the time out to do it. They don't understand the math. It's just something that they have to practice. And hopefully that's something that they do in their classrooms where they can build their math stamina when it comes to doing all of this work. So let's do another question. So here's another question involving exponents. So we have, it says, which expression is equivalent to 5 to the 4th power times 5 to the negative 3rd power raised to the 2nd power. So the first thing I would do is this portion here, which is the power of a power. You still have to follow order of operations when you're working with exponents. So this is going to be 5 to the 4th times, and this is going to be 5 to the negative 6. And again, they have the same base, so you need to add them together, add the exponents together. So that's going to be 4 plus negative 6, or you can just write 4 minus 6. And this is going to be 5 and negative 2 as the exponent. Well, if you look at your answer choices, none of these is that. But remember, I can rewrite this portion as 1 over 5 squared. Okay? 1 over 5 squared is the same thing as saying 1/5 and then squaring it. Okay? So just to show you what I mean by that, I can take this portion here, and this is what it would be. It would be 1 over 5 times 5 would get you 1 over 25. Okay? Now I could take this same question here, this one here, and write 1 times 5 times 1 times 5, and I still get 1 over 25. So D would be my answer choice. Let's go to another question. Okay, so for this problem here, we're involving decimals. Are they allowed to use a calculator? They may or may not use a calculator with this type of problem. Oh, sorry about that. So you have to find the value of P in this equation. So I think the one thing that does look familiar in this problem is the number 64. 64 is familiar in this problem, but I think we're used to dealing with 64 when we're talking about the square root of 64. Pretty much everyone knows like what two numbers I can multiply to get 64. And usually most people go to 8 times 8. But in this particular case, you need the cube root because of this root value here. The exponent says 3, so that means you need the cube root. So you need to figure out, well, what number can I multiply 3 times in order to get 64? In this particular case, if you didn't know, you can always do a factor tree. And this is what I mean by do a factor tree. You just take 64, and we know we can do 8 times 8. But can I break down the 8 some more? I could. I could break this down to 4 times 2. Over here, do the same thing, 4 times 2. I can also break this 4 down to 2 times 2. And then bring that 2 down. Break this 4 down to 2 times 2. And then bring this 2 down. Well, at this point, I have 1, 2, 3, 4, 5, 6. I have 6, 2. But guess what? I can make 3 pairs. So I have this pair. I have this pair of 2. And I have this pair of 2s. And what does 2 times 2 equal? That equals 4. So guess what? What one number can I multiply 3 times in order to get 64? And that answer is going to be 4. But how can I relate this to a problem that's dealing with the decimal? So what I can do is test it out, okay? So remember, this is a standard that the kids may or may not can use a calculator with. So if they have a calculator, then by all means, use a calculator. But I won't use one. I'll just do it by hand. So I need this. Let's test out 0.4. If I multiply 0.4 times 0.4, then I'm going to get 16 carry the 1. Get 16 here. Then I do my placeholder. Of course, I am old school when it comes to math. Doing the old school math. Okay, so this I need to go 2 decimal places. So 1, 2. So currently I have 0.16. Now if I multiply this number 0.16 by 0.4, let's do it over here. 0.16 times 0.4, then I get 24. That's going to be 6 and 0. Let me do a placeholder, and then I get 0, 0, and 0 again. I add them together. And this time I need to go 3 decimal places because of this. 2 DPs, that's what I call it. 1 DP gets you a total of 3 DPs. And DP is decimal places. So I go 1, 2, 3. So guess what? I have my answer. So the answer for P is going to be 0.4. There you go. There you have it. Let's keep it moving. Again, tonight we're doing 8th grade math unless someone texts me. So my phone number is 407-801-9255. You got a problem you want me to do, just go ahead and do it. Just text me. Or you can just say hi in the comments if you know me. Say, hey, Kim. I appreciate that. Just say hey. Okay, so for this next problem, it says the average mass of a giraffe is approximately 1 times 10 to the third kilograms. The average mass of a blue whale is approximately 2 times 10 to the 6 kilograms. How many times more mass does a blue whale have than a giraffe? Okay, so now we're working with scientific notation. So with scientific notation, it's just writing, it's a different way of just writing a big number. So you just kind of like, it's like shorthand. So instead of writing all these zeros, you write 10 to whatever power so you can shorten the number up. So the first thing I'm going to do is I want to rewrite the numbers in standard form. So right now they say how many more times is it bigger. I want to show you what the number looks like in standard form. So for the giraffe, it is, and this is the mass for a giraffe. Right now it's going to be 1 times 10 to the third power. So this is really 1 times 1,000. And that's going to get you 1,000. So that would be the mass of a giraffe, according to our text. Now for a blue whale, we have 2 times 10 to the 6. And that is really 2 times a big old number. What's that? 1 million? So that means it's going to be 2 million. And this is the mass of a blue whale. They want to know how many times more mass does a blue whale have than a giraffe. So you just go 2 million really divided by 1,000. Okay? When you do that math, it comes out to be, and let me just show it because that's just what I do. Let's see, 1,000, and we have 2 million here. Let's just go ahead and do this real quick. So how many times does 1,000 go into 2,000? That's going to be 2. And then you do this part here, subtract, and you get all the zeros left. So the answer here, how many times more mass does a blue whale have than a giraffe? You're going to say 2,000 times more mass. That's a lot. So anyway, let's go to another question. Again, if you have a math problem you would like for me to do for you tonight, you can text me at 407-801-9255. I'm here for you. I know people will be struggling with math, so I'll be trying to help y'all out. So I'll just take a few more minutes to do a couple more problems, and then I'll be out y'all way. Let's do this question here. It says, what is the sum of 4 times 10 to the negative 5th plus 3 times 10 to the negative 5th written in standard form? Standard form means to write a number in the way that we normally see numbers. So I have 4 times 10 to the negative 5th. And all that means is take this 4 and move your decimal to the left 5 times. So right now my decimal is behind the 4 or to the right of the 4, and I need to move it 5 times to the left. So 1 time, 2, 3, 4, 5. This is where my decimal goes, and in empty spots, I'm going to put a 0. So this number as a decimal is 0.1234, and then you put the number 4. So now let's do the other one. This is 3 times 10 to the negative 5th. So you put the 3 here, decimal here, move it 5 times to the left. 1, 2, 3, 4, 5. That's my decimal. Add in my zeros. And so I get 0.00003. And they say they want to know the sum. So you know sum means that you need to add these numbers together. And so we just gonna add them together. And 1, 2, 3, 4, and 7. And that is our answer. Alright. Let's do another question. Okay, so it says here, the graph of a proportional relationship is shown. So it says, what is the amount of savings per week? So this is talking about or referring to slope. We call it slope, or we could call it rate of change. Okay? So in this case, we're trying to figure out the rate of change, or the slope. And in this case, it's going to be savings over number of weeks. So it's going to be savings over the number of weeks. Okay, so that's what slope is. The y values over the x values. So in this case, if I'm looking here, I see that we got this ordered pair here, and here, and here, and here, and so on and so forth. But what does this mean? This means that $94, so I have $94 is saved in 2 weeks. But they want to know what is it in 1 week. That's what the per week means for 1 week. So in order to do that, I need to divide both my numerator and my denominator by 2. And 94, let's do this as 2, 94. This is going to be 4 and 8 and 1. Bring down the 4. This is going to be 7. And this means that I am saving $47 per week. And that's what it means. That's what it is. Alright, let's keep going. So for this question here, it wants to know, it says the graph of a proportional relationship and an equation are shown. So we got 2 different things here. We have a graph and we have an equation. It says, what is the greater unit rate? Unit rate also can be referred to as the slope. So let's look at this particular problem here. In the graph, I need to figure out, well, where is it crossing? So what I see is, I see an ordered pair here. And I also see one here. So for unit rate, that means how much it costs for one item. Like for instance, if you had went to the let's say you went to the arena to buy some concert tickets and you spent $200. If you spent $200 on 5 tickets, they want to know how much if you paid for 1 ticket. And so that's an example of unit rate. So of course that would be 40, right? So this is an example of unit rate. How much does it cost for 1 unit? So in this case, when I look at this particular dot here, the unit rate for this dot here would be up 3.5. Okay, and then they went to the right to 0.5. Now this, although I'm working with decimal, this is not really that difficult, at least not to me. Because what I do know, this is when you need to have a good handle on number sense. You already know, especially if I put this as money. This is $3.50, and then over 50 cents. You pretty much know what to do with this now. You're like, oh, how many 50 cents do I have in $3.50? And you be like, oh, that's 7. Okay? But what I also know is that if I was to multiply this number by 2, I could get a whole dollar. So I could get a whole dollar if I multiply it by 2, right? And over here, this would be 7. Okay? So the unit rate for the graph, and I'm right here, the unit rate, and this is for the graph, it's going to be 7 over 1. Okay? Now, what is the unit rate for the equation? What is the unit rate for the equation? So this is 11 over 2. Now, what I could do here is divide both the numerator and your denominator by 2, because that's going to get me a 1 in my denominator. So this is going to be 5.5 over 1. So the unit rate here is 5.5 over 1. So which one has the greater unit rate? And the answer is going to be the graph. And that's it. That's it, that's it, that's all. I think I'm done. Is that it? I think that's all I had for tonight. So, I mean, I could hang up, or if you have some questions for me, I see some people logged in. I thank you for being logged in. Can you say hey to me? I'm going to say hey to you. So let me see. Hi. I'm going to put hi in the comments. Can y'all reply to me? Is it going to type? Let's see. Hi. Let's see who responds to me. That'd be so nice if y'all say hey back. Just say hey, Kim. That would be so wonderful. Please just say hey. Do you know anyone who needs help with math? Do you know anybody who needs help with math? I think I could put a question out there. Uh-oh. I'm around here playing around. Let me stop playing around. Okay. Let me stop playing around with this live stuff because I'm going to mess something up. Well, anyway, that is all that I have for you tonight. I'll be on live again next week. And if you need some help or you know someone that needs some help with some math, I am here. I'm available. I'm offering my service for free. You don't find that often, but I just wanted to help people because I got people who tell me, I have people who text me throughout the week, and I guess they want me to do a problem right then. I usually don't do that. But if you need help with some math, you can text me, and I'll do your problems on Monday night. But until next time, ta-ta for now, and you have a wonderful, wonderful week. Bye-bye.